We're back. Unfortunately, I didn't realize that everything had cut out and I kept doing the question. So, what you will see here is the sequence of coin tosses and their outcomes. So, this represents me following the top branch and just reading out the letters that I encounter. So, head, 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 and that's my outcome. So, these are my outcomes. Okay, so in order to find the expected number of heads, right, I would have to summarize my outcomes at the end of each of my branch. So this second outcome is a result of head, 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 tail, then I write it, followed by the third outcome, head, head, tail, head. The fourth one, head, head, tail, tail. The fifth one, head, tail, head, head. The sixth one, head, tail, head, tail. Seventh, head, tail, tail, head. The eighth, head, tail, tail, tail. The ninth, tail, head, head, head. The 10th, tail, head, head, tail. The 11th, tail, head, tail, head. The 12th, tail, head, tail, tail. The 13th, tail, tail, head, head. The 14th, tail, tail, head, tail. The 15th, tail, 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 head. And the 16th, tail, 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 tail. Now, because the priority is the number of heads you're getting, I just translated the specific outcome to summarize the number of heads that were represented by that outcome. So 4 heads was the first, 3 heads was the second, 3 heads was the third, and so on. So you might want to copy down. So it would be 4 heads, 3 heads, 3 heads, 2 heads, 3 heads, 2 heads, 2 heads, 1 head, 3 heads, 2 heads, 2 heads, 1 head, 2 heads, 1 head, 1 head, and 0 heads. Okay. Now, here's the point of all of this. We're trying to find the expected number of heads, or the expected value of the discrete random variable. Okay, in doing so, we have to understand that it represents these formulas, but I promised that we would make it simple. So here we go. So I say that the discrete random variable, okay, is x, and we have to assign a value to the discrete random variable. So we have to assign a value in terms of number of heads, okay? So this discrete random variable x can take on the value of 0 heads, 1 head, 2 heads, 3 heads, and 4 heads, okay? And then I need my probability, okay? Now my probability is when the x value represents all of these little values. So this here is x1, this is x2, this is x3, this is x4, and this is x5. So if I'm looking up here, right, this is where my probability, my p, is my probability of the discrete random variable is equal to little I. Okay, so what's the probability that I would get 0? What's the probability that I would get 0 heads? Well, it is 1, right? So 1 out of 16. And all my check marks were actually for me to track all this. This is not going to be easy to erase. We'll see if this works. We'll see. Okay. What's the probability of getting 1 head? 1, 2. So I have 0 heads taken care of. Okay, so 1, 2, 3, 4. So 4 out of 16. Okay, so what's the probability that my discrete random variable is equal to a 2, represented by 2 heads? So there's 1 there, there's 2, there's 3, there's 4, there's 5, there's 6. 6 out of 16. Okay, so what's the probability that my discrete random variable takes on a value of 3, as in 3 heads? So 3, 1, 1, 2, 3, 4. And what's the probability that my discrete random variable takes on the value of 4, represented by 4 heads? Okay, I think it's 1. So if we were not sure, we could add these to get the total probability. They're all denominators of 16, so we just have to add the numerators. 1 plus 4 is 5, plus 6 is 11, plus 4 is 15, plus 1 is 16. So that means it's equal to 1, which is what we had up here. Sum of theoretical probabilities is equal to 1. Okay, so we want to know the value of the expected number of heads. So what we do is we say, alrighty, the expected value of x, where x is defined as the discrete random variable, so that's x, okay? So the expected value is the following. It's equal to 0 times 1 over 16 plus 1 times 4 over 16 plus 2 times 6 over 16 plus 3 times 4 over 16 plus 4 times 1 over 16. Okay, now remember, you're multiplying by fraction, so a fraction has a 1. If it's a whole number, it's got a fraction of denominator of 1. Multiply numerators together, denominators together. So here we have 0 times 1. 0 times anything is going to be 0. Okay, 1 times 4 over 16 is 4 over 16. 2 times 6 is 12 over 16, plus 3 times 4 is 12 over 16, plus 4 times 1 is 4 over 16. So we have 24, 24 and 8 is 32 over 16 is 2. So what is the expected value of this discrete random variable? Well, it's a value of 2, which makes a lot of sense, because what are the chances of you tossing 4 coins? The theoretical probability is that you would get 2 out of 4, which is 50%, heads. So the expected value of your number of heads is 2.